Most of you are probably aware of packages like Getit or even Provider, which are amazing tools for doing basic and manual dependency injection. When your app is small, filling in all of the constructor parameters yourself manually may not even seem to be such a daunting task. Once your app starts to grow though, and as a proper programmer, you probably want to keep it clean by creating smaller and sensible classes, doing it all by hand, that is filling in all of those constructor parameters, can become a nightmare. In this tutorial, you are going to learn how to utilize the power of code generation together with the Kiwi package to configure your dependency injection container in no time. Hello, welcome to ResoCoder, where you are getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming sought after developers. And also, if you're not aware of it yet, an amazing Flutter conference is going to be taking place in January the next year, that is 2020. It's going to happen in Warsaw, Poland. And I will be there, people from Google will be there, and overall it will be packed with awesome presentations, and you will have an amazing opportunity to meet up with the Flutter community. So check out the link from the video description, or you can also go to fluttereurope.dev to learn more. In this tutorial, we are going to use the Kiwi package to make dependency injection happen in a proper way for an app which I have already pre-built for you, so that we do not need to waste time with building all of these classes which are here. It's a basic, very basic weather forecast app, which simply upon launch displays two forecasts on a screen, and there is the temperature, the conditions, so clouds and clouds again, and the time of the forecast. This app is built cleanly, that is with clean architecture, so we have features, weather forecast, data sources, models, domain, presentation, all of that stuff is over here. And no matter if you are proficient in clean architecture or you have never even heard of it and you like to eat some spaghetti as you code, if you know what I mean, you are going to be able to follow along with this tutorial. However, I highly recommend you to get yourself familiar with clean architecture, and you can check out my full course about clean architecture on Flutter from the card in the corner. We can see all of the classes and how they are dependent on each other from the presentation layers weather forecast widget. Over here, we are basically doing the whole dependency injection ourselves. It's not even dependency injection. We are just instantiating a bunch of classes directly and putting them into a change notifier provider. So we are going to take all of this code and put it into a nice service locator. And if you want to follow along with this tutorial, be sure to get the starter project so that you do not need to recreate all of these classes which are right over here in the weather forecast feature. So be sure to check out the written tutorial from the link in the description, where apart from the starter project, you can also find all of the code written in this video and links to the libraries, and overall go through this lesson at your own pace. The most important thing when you want to do any sort of a dependency injection is to loosely couple your classes. And I have already done that in the starter project, because when we, for example, take a look at the forecast repository, it depends on forecast data source, but it does not instantiate it directly. Instead, it takes it through the constructor. Similarly, there is a use case, get forecast, which depends on the forecast repository, which we have just checked out, and also on location, which is instance just for testing. We are basically hard coding in a location for the weather forecast. Usually you would want to have a location repository over here, but that doesn't matter. We depend on two classes here, so we pass them through the constructor. This is called loose coupling, and without loose coupling, you have just absolutely no chance in achieving dependency injection, no matter what package you use, whether that is Getit, Provider, or even Kiwi, about which you are going to learn in this tutorial. To start off, we need to, of course, add the Kiwi package, and then we are going to recreate these manually injected dependencies to something which is actually manageable, readable, and proper code. So let's go over to pubspec.yaml, and I'm just going to paste dependencies from the written tutorial. So definitely check it out if you want to get the same dependencies, and also be sure to use the same versions because something may change in the future. So if you want to follow along, use the same versions of all of the packages. As you can see, we are already using provider, but in addition to that, we want to add Kiwi as a regular dependency. And then we also want to add Kiwi generator because that's what's going to allow us to utilize code generation to make even quicker and cleaner service locators without needing to specify all of the constructor parameters ourselves, such as you need to do when you are using getit or provider. So into dev dependencies, we are going to add Kiwi and also build runner, or Kiwi generator to be more precise. So once we save this file, we're going to get all of the packages downloaded for us, and we can now close pubspec.yaml. Let's now create a class which will center all of the code related to service locator or to dependency injection. So we're going to create it at the root next to main.dart. So let's right click on lib. We're going to create new file. We're going to call it injector.dart. And inside of it, we're going to have an abstract class injector. And also, since we are going to use code generation, we probably need to provide a part statement. And we're going to call the generated file injector.g.dart. And with that, we are now going to import Kiwi because we of course need it. So import kiwi.dart. And this injector, let's first create the basic setup code, which is needed no matter if you use the code generation or not. You would probably create a similar setup for your injectors. Even if you are using something like getit, you still need to register all of the dependencies, all of the classes before you can actually resolve them. Kiwi works with containers, and you can register your classes into a container. So we are going to, for example, register a weather forecast change notifier into the container. And then later on, when we need it from this UI widget, we're going to resolve it from that container in which it is registered. So we're going to hold an instance to the container just so we can reference it more easily. Static container. Let's call it container. And we need to have some sort of a setup function, which we are going to call as soon as the app starts, so that all of the dependencies will be registered inside this container. So we're going to create again static void setup. And inside of here, we're going to set our sort of cached instance of container to be equal to container invocation, which is not instantiation. Keep this in mind because container is actually a singleton as it writes right here. So yeah, we are not instantiating multiple containers. We are just referencing it inside a variable here inside a static field so that we can have more clear way of accessing that. And then what's important, since we are using code generation, we are not going to just register stuff on the container right inside setup. We could do that, of course, if you don't want to use code generation. So you could say register factory, and factory will be registered for, I don't know what class, for example, the weather forecast or change notifier, right? You could absolutely do that and then populate c.resolve all of the different constructor parameters. So again, c.resolve, and you would be then good to go. Of course, it actually takes in only one parameter, so excuse me for that. And you could do something like this directly if you did not want to use code generation. But as you can see, we are writing a sort of a redundant code in here because we are calling c.resolve for every single constructor parameter, right? We do not want to do that, and we can actually spare ourselves from these redundant keystrokes by utilizing the power of code generation, which is what this tutorial is all about. So let's delete this code, and we are instead going to utilize the generated injector class. First though, let's create a non-static method, so instance method, right over inside this abstract injector class. It will be called void configure. And inside of this, we are going to kick off our registration of dependencies. And this configure will be also present inside the generated injector class. So that's what we want to call from within the setup. So the generated injector class will be called $$injector. And we are going to call configure on it after we instantiate it. Of course, it's currently not present because we have yet to run code generation. So let's actually do that right now. And I have found out a very, very awesome quick way of building Flutter projects. So you can go Control-Shift-B and you can choose Flutter Build Runner Watch. And with that, you're going to execute this awesome task, which you are used to typing into the terminal directly, but you do not need to type anything into the terminal. So just hit Control-Shift and B, or Command-Shift-B, I guess, if you are on Mac, and you are going to be good to go. It seems that because we are not currently registering anything using the code generator annotations, it's not going to generate the generated file for us yet. So let's just quickly demonstrate how we can register this precise weather forecast change notifier as we did previously, but without all of the redundant filling in of those constructor parameters. So we can do something like @register. And now we want to register a factory. We want to specify its type, which is weather forecast change notifier. And then you can also specify a bunch of other things which are currently of no interest to us. We are going to get to them later on in this tutorial. Oh, and of course, we cannot provide an implementation which is empty to this configure because we want to generate it. So when we now save this, we can see that the injector is now present. And when we take a look at the configure method inside the generated injector class, which is present inside injector.g.dart, which currently has an error because it doesn't have the get forecast use case. So let's just import it over here, and we should import it over to the non-generated file, of course. So let's just quickly do that. And once everything is properly imported, we are inside the generated class. We can see that the configure method does precisely what we were doing previously, as I showed you how to register factories with Kiwi without using code generation. But we do not need to do that ourselves. We do not need to call the container resolve, or actually just C and parentheses because container is a callable class. But we do not need to do this. We just specify the name of the class, or the type of the class to be more precise, and we are good to go. Before we jump into registering all of the other classes, let's just quickly make sure that we do not forget about calling this setup method as soon as the app starts, because that's what you should always do. And the starting point of every Flutter app, or every Dart app for that matter, is inside the main.dart file, and it's this main method. So let's just quickly convert it to a block body. And before calling run app, we're going to call injector.setup, and we can call it like this because setup is an abstract method, or a static method, excuse me. So once we save that, and now if we were to run the app, the setup method would run. All right, so you already know how to register dependencies. We can use register.factory. And then there's also @register.singleton. And basically the only difference between a singleton and a factory is that a factory gets called every time the dependency gets resolved, and singleton gets called only once when it's the first time that the dependency is resolved, and then it returns the same instance, which kind of makes sense since it's a singleton. And while nothing prevents us from registering all of our classes directly on this configure method, we are instead going to create modules which we are going to register separately, and all of those modules will be controlled and orchestrated through this main configure method. Now, why we are doing that? Well, if you take a look at the code which we have currently here, we have a weather forecast feature which contains a bunch of classes. Now imagine if we have 10 features like this and each of those 10 features contains like 5 classes. If you try to register all of them by annotating just a single method, it will quickly become one huge mess. So that's why we're going to separate, and you should also in your own projects always separate the registrations into modules which are basically mapped on a one-to-one basis to features. So let's delete this register of a singleton and let's create our first module. And I have actually created a handy snippet for that, which you can get from the written tutorial. So all I need to get is call Kiwi, M, hit enter, and now we can create or populate all of these names with whatever our module is called. Since we are registering classes from the weather forecast feature, let's call this module weather forecast feature module. As you can see, every module has a main method which calls the module submethods, and those submethods are where we actually register something on the container. We can register instances, which is something you may not have seen yet. I haven't shown it yet in this tutorial. And then we can register factories. And if you really want to register singletons, which we are not going to do, and basically in the apps which I'm building for clients, I'm not really using singletons almost at all. But if you want to use also singletons, you can create separate methods even for them. Now what we are going to do to clean this code up is that we are going to copy or actually cut out this factory registration and put it into, or put it above, the configure weather forecast feature module factories method, which doesn't have an implementation because it should be generated. And now this configure method will have an implementation and it will call all of the main module methods. So we want to call this method for our weather forecast feature module so that it kicks off the registration of the dependencies. Okay, and before we move on to register all of the other factories, let's talk about what is an instance and how it differs from a factory or a singleton. So as I've already said, and as you know, factories get called every time they are resolved. Singletons get called only on the first time they are resolved, and then it returns the same instance. However, instances are different, and instances do not have an annotation which can be used when using code generation. There is just factory, singleton, and that's it. So registering instances is left for us to do manually. And that is for a very simple reason. That's because instances can have certain constructor parameters passed into them. And as you can probably tell, we cannot ever pass any custom constructor parameter, which is hard-coded into a constructor, over to a factory nor to a singleton. Because all we do in this add register factory annotation is that we specify the type which we want to register, but we cannot just instantiate it over here. That's invalid. We cannot pass in anything. We can just leave it up to the code generation. However, if you do not want to leave it up to code generation, you can always register an instance and pass in custom parameters. We will want to do such a thing with a location. If we take a look at the location entity, we can see that it takes in a longitude and also a latitude. And there is one class which depends on it, and that's the get forecast use case. Because we are only inside the tutorial, we are not doing any error handling, and we also do not have a location repository. we are just simply passing in the hard-coded location into the getForecast use case directly. And of course, we cannot and do not want to leave populating the location fields up to code generation. Like, of course, we want to specify the longitude and latitude ourselves, right? So that's why we're going to register it as an instance to the container. So let's do just that. We're going to instantiate location and specify latitude. Let's just set it to be 0 and longitude also 0. And let's now move on to registering all of the other factories. So we are starting off with the top level weather forecast change notifier. If we take a look at that, this depends on the getForecast use case. So we need to now register getForecast use case inside our injector class. So let's just move it down and register factory getForecast. And now getForecast depends on the forecast repository and also on location, which we have already registered. However, we have not yet registered the forecast repository. So let's do just that. We're going to register factory forecast repository. And here's a problem, which is actually a good thing because that means we are doing clean architecture properly and we are separating our layers. But the issue is that we have forecast repository, which is only an abstract class. And then we also have forecast repository implementation, right? So let's actually take a look at them. We can see that the abstract class is just defining a method which the implementation should have. And then the implementation, which is located in the data layer, has the implementation of that particular method. So of course, we actually want to instantiate the implementation, but we want to register it with its superclass's type, which is the abstract class, the contract, so to say. And if you are getting a bit lost, definitely check out the Clean Architecture series in which you are going to learn how to architect your apps properly so that the code structure which you have in your Flutter apps will be very simple to maintain. So how can we register such classes which are separated into abstract and their implementation? Well, we are going to register a factory for the abstract class, so for this precise forecast repository, but then we are going to specify from which class we actually want to provide the implementation. So that is going to be forecast repository implementation. That means whenever we request or when the Kiwi library automatically requests a forecast repository, it will be presented with a forecast repository implementation. And then if you have multiple implementations, it is very easy to switch between them because you can have implementation like 2, implementation 3, or whatever your naming scheme is. You may have something with fake data, then you may have a production implementation and so on. And it's very easy to switch between multiple implementations when you register your factories or singletons this way. Then a similar thing happens with our next class, which we need to register, because the forecast repository, or actually its implementation, depends on some sort of a forecast data source. And again, we have a forecast data source abstract class and also its implementation. So we are going to register forecast data source abstract and also then forecast data source implementation, which is actually in a good way called fake forecast data source, so that it's immediately apparent which kind of data we are dealing with. Okay, so now we could technically call it a day and just jump right into weather forecast widget and resolve every single thing which we have just registered. But also there is another thing which is very much amazing, which I want to show you with Kiwi. In addition to just simply registering classes like instances, factories, or even singletons, just like that, you can also provide a name to them. So let's just demonstrate this by registering another instance of a location class, which is actually going to be London. So I'm going to just copy its latitude and longitude from the written tutorial, to which you can get from the link in the video description. So let's replace latitude and longitude here. And now, whenever we want to use London location instead of this 0 and 0 latitude longitude, we can use it when we specify a name for this instance, and let's just call it London. What we have just done is that whenever we request for a location instance without specifying a name, it's going to resolve it to be the null location, so 0, 0. However, if we provide a name when we request for a location and that name is London, it's going to be resolved to this London location. But now the question is, how do we actually get the London location? Because currently, as we know, the getForecast depends on a location. So how can we tell the getForecast class as it's resolved to request London's location and not the 0, 0 location? Well, we can do that very simply by specifying resolvers, which is a very simple map, which maps a type, so location in this case, to a string, which is the name for that type which we want to get. So in our case, it's going to be London. And now every single time that getForecast is resolved, it will be passed in an instance of the London location. And of course, providing names to your registered things in the container is not reserved to just instances. You can also provide a name for factories and also, of course, for singletons. Now, when we save that, we can just check out of curiosity the generated code. The factories are all generated with the proper constructor arguments being passed in. The location is also provided a name London, which is definitely good. And of course, we cannot see the instances being registered in the generated file. That's because we are registering those instances by hand, because we need to pass in those latitude and longitude arguments. And now with all of this registered, we are going to move on to the last stage of this tutorial, and we are going to resolve the top level dependency, the weather forecast change notifier, which is in turn going to kick off resolving of all of the other of its dependencies. And while we definitely could just go over to the weather forecast widget where we are currently registering everything by hand, which is totally horrible, and we could just delete all of this code, which is manually instantiating all of the classes, and we could now import Kiwi over here. So import Kiwi as Kiwi and just get hold of Kiwi.container, which is actually a singleton, as you know. And we can now call resolve, and we want to resolve our type of weather forecast change notifier. And we could definitely do that. That's perfectly reasonable. But to keep this cleaner, we should probably keep all of our dependency injection related code inside our own custom injector class and not expose Kiwi to the outside. So that's what we are precisely going to do. We're now going to import Kiwi even inside our weather forecast widget. Instead, we are going to use our injector, in which we need to provide a method which will basically just extend the Kiwi method. It will be just a pass-through. It's going to be static final, because we are actually just going to reference the method. We are not going to call anything, because as you know, in Dart, functions are first-class citizens, which means that everything is also a class. So let's call it resolve, and we are going to set it to container.resolve. So now what we have just done is that we are basically extending the container.resolve coming from Kiwi to be also callable just on our injector class. So let's get hold of our injector. And now we can call resolve, specify the type which we want to resolve, which is the top level dependency, which in our case is the weather forecast change notifier. And this will kick off the resolving of all of its child dependencies. And once we save this file, and I will just quickly hot restart to make sure that everything is present rightly, we can see that we are still presented with temperatures and the app still works. And what we've done is that we have completely cleared up and made the dependency injection manageable by putting all of the code into an injector abstract class, which is using code generation coming from the Kiwi generator, which spares us from populating all of the constructor parameters by hand. To go through this tutorial at your own pace once again and to get all of the code, check out the written tutorial available from the link in the description. And if you are serious about becoming a great Flutter developer who can build real apps for clients or at a job, go to flutter.education, link is also in the description, to get the top curated Flutter news and resources aimed at improving your app development career. Over there you can also subscribe to my mailing list to get the best Flutter resources delivered weekly right into your inbox. And if you do not want to miss more tutorials like this, be sure to subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder I am determined to provide you with the best tutorials and resources so that you will become a sought-after Flutter developer. If this video helped you with understanding dependency injection, how to use Kiwi and together with Kiwi generator package, give this video a like and also share it with other Flutter developers who will surely benefit from this too. Leave a comment if you have anything to say, and see you in the next video.